what types of functions did we say that both sine and cosine are? Do you remember the word we used to describe them? Not our parent functions. I mean, they have parent functions, right? But it does start with a P. Remember, we call them periodic functions because they like repeat themselves over and over and over again. So there's two different types of places that you can see like these applications. The first is in things like sine, like waves can be used to represent like sound waves as well as like light waves. Now, those applications are a little bit more complicated, so we're not going to look any like that. But then the other place that we can see them is because they're periodic functions, we can use them to represent stuff that like repeats itself. So one of the things that we're going to look at is like the tides, so like how high and low the tides are for water, because those are based upon the time of day, and they'll repeat themselves over and over and over again. So you end up with like a sine wave. Then you're actually going to be doing a lab over temperature, because temperature, again, for most places is going to get warmer, right, in your summer months and then get colder in your winter months. And it's going to repeat itself on a 12-month period or a cycle. So you also end up with a sine-looking graph. Are we all okay with that? So we're going to look at an example just from a graph first, kind of to help us get like all of the equations that we need. And then we're going to look at it with like an actual application. So can you remind me what our formula is for all of our transformations for our sine graph? You can technically use cosine for any of these two, but we like to use the sine graph because remember sine starts at 0, 0, and starting at 0, 0 is just helpful. So that's why we usually use sine when we're going to do trig applications.
Is it y equals a sine parentheses b x minus c plus d?
Yep. So remember we have A, B, C, and D. We were super creative in our variable picking there. But those represent our 4 different types of transformations. And hopefully we can notice that this is a sine wave. It has the correct shape, and so that's why we're going to use our sine parent graph. Our y is what represents the function, and our x is what represents our inputs. So we want our y and our x to stay there, but we do need to find A, B, C, and D. Again, we're working from a graph. So basically we're taking our graph and we're trying to work our way backwards to make our equation. Yes? Usually we want to work from the outside in. So remember on the outside, those are the things that affect our y values. On the inside are the stuff that affects the x values. And our A and our D are usually a little bit easier to find from the graph. Yes? Okay. Now remember that we looked at, when we did our graphs, whenever we have a D value, remember that's kind of like our new midline, or the new middle line for our whole graph. Yes? We treat it like our imaginary x-axis when we have to move it up or down. So the first thing that we want to do is find what the middle of this graph is. How might I do that? How do you find the middle of any two numbers? Add them up and divide by 2, yeah? So if I'm wanting to find the middle of this graph, right, I want to take, same idea, I want to take the highest and lowest values, and we're going to add them up and divide by 2. Are we all okay with that? Because notice, if my highest value is 2, and our lowest value is -4, okay, and again, if it's on the outside, we're dealing with our y values, so I'm taking my maximum y and adding my 4 divided by 2.
-1.
-1. So I'm going to draw that in. So we have like this imaginary line that is our middle point, or middle of our graph. Are you okay with that? So like this part right here would be the actual like formula that we want to use in the future as well. Now, what does our A represent? Amplitude, which tells us what?
How high?
How high and
How low?
low it goes, okay. So normally when we're like on our x-axis, right, I can just look at the number, right, because usually I would have like 2 and -2. So like I'm going 2 up and 2 down, and so my amplitude is 2, yes? Now here we've shifted everything down by 1. So we kind of need to look at like what it looks like compared to that. So how far up is our maximum from our line of -1? 3. And then how far down is our minimum from our -1? Also 3. So our amplitude is going to be 3. The other way we can kind of think about it, remember that the actual like definition of amplitude is that it's half the distance. So remember that distance means that I subtract my 2 values, and it's half the distance, so then I'm dividing by 2. So that's the actual formula, but for us this time, we found that it was 3. So 2 down, 2 more to go. Yay! Alright, so now working our way inside, our next variable is b. And what does b normally give us? The period. So remember that our period is equal to 2 pi divided by b. Yes? But I'm trying to work my way backwards this time. So instead of plugging in b and finding the period, we're going to plug in the period that we get from our graph and solve for b. Are we all okay with that? But we do need to decide what the period is. So remember, our period is how long it takes for something to repeat itself, correct? And most of the time with sine, remember that we started at 0 to 0, and so we look at the x-intercepts. But like notice on my x-intercepts, do I have very nice numbers there? No. And that's because we've probably shifted, right? We probably have a c value, so we're not like on nice pretty numbers on our x-axis. We've also shifted down, so that also affects those. Are we okay with that? So instead, we're going to use values that are really easy for us to like see. So what values have we been using that are like easy to pick out from our graph? Yeah, so we've been using our maximums and our minimums. We were using the y values for our a and our d, because remember those are on the outside, those are our y value stuff. The stuff on the inside is our x values. So we're still going to be using maxes and mins. It's just now we're going to look at the x values now instead. Are we okay with that? Yes, no, maybe. So notice that for this graph, okay, to go from one minimum to the next minimum, so from here to here, okay, I've gotten all my values, and then notice that after that minimum, it starts to repeat itself again. So this distance right here would be one full period of the graph. Are we okay with how I know that that's the period? Yes, no, maybe? Okay. now I'm dealing with distance. So I want to know the distance between those two x values. So how do I find distance? Subtract them, right? I do want to take the bigger one and subtract the smaller one. So the way that I'm going to describe that, so the period, we're dealing with x's this time. So this is my minimum x2, so like my second minimum, minus my minimum x1. Are we okay with that notation? Because they're both x values and they're both minimums, so that's why I did the 2 and the 1, just so we can kind of differentiate between the two. So again, that's kind of our formula that we have for that. Okay. For us, for this one, our x2 is what?
5 pi over 4.
Okay. And our x1 is
5 over 4.
what is 5 pi over 4 minus pi over 4?
Pi.
Yeah, 4 pi over 4 or pi. So that might be value.
That's the period.
That's the period. So now I need to use that to solve for my b value. So now I can say that pi equals 2 pi divided by b. So it's just an equation, so I'm solving. So I get that b equals 2. Yes, no, maybe. Questions on our stuff up until now? So there's a lot of formulas and there's a lot going on, which is one of the reasons why you will not have a question like this on your test. So that's why we're going to do a lab over this instead. Basically, so I still want to make sure you know what's going on and how we do this, but I want you to have all the formulas and have time to deal with this sort of thing. So you do need these formulas written down, but you don't have to have them memorized or anything. Alright, so what's our last variable that we have to find? C, okay. C is kind of the hardest one to find because we have so much other stuff going on. So 1, we've shifted it over. 1, 2, we've shifted it down. And then also our period is different. So we can't just look at points in order for us to tell what it is. Yes, no, maybe. Okay. So what I want to do is I want to take this value that's on the inside. So I have b times x minus c. And we're trying to figure out how far we have shifted stuff over. So we need a reference point, meaning that I need a point that was on our parent graph, and we want to see how far that point got shifted over on our new graph. Are we okay with that? Again, what points have we been using that are easy for us to find on our graph?
Minimums and maximums.
Minimums and maximums. Okay? So which one do we want to use? It doesn't matter.
Maximums.
Maximum. Sure. So I have a 3 pi over 4 comma 2. We're okay with that. So looking at your parent graph for sine. Yes, no, maybe. Where does sine normally have a maximum value? For the parent graph.
Up to 1.
Is that 1? And then what's the x value? Or think about your unit circle. Where does sine equal 1? Hmm? 0 at pi. Pi over 2. So the way that we're going to do this is we're going to set, again, I said that we have to have a reference type of point. So we're going to set it equal to some old value. And then I'm going to plug in what that new value is. And you can either use a minimum or a maximum here. And then we're going to solve for c. So that's how we find our c value. the b value that we just found. So what's our b? 2. Okay. We said that our old maximum is at pi over 2. Agreed? Where's our new maximum? Or like the first one?
3 pi over 4.
3 pi over 4. Okay with that. So I'm just setting up an equation now where I can solve for c, which basically tells me like how far did it take me to get from pi over 2 to like my new maximum. So what would our first step be?
Distribute it 2.
You could. Well, might a little bit easier though. It's already factored out, right?
Divide by.
So I could just divide from the beginning. Otherwise, like you would just be multiplying and then multiplying that by 2. At the end of the day, you're gonna end up dividing by 2. Either way would work. So dividing by 2 is the same thing as multiplying by. Okay, so pi over 2 times 1/2 is pi over 4. So we're okay with that. So if I have pi over 4, I'm then going to subtract 3 pi over 4. What does that give us? So if I have 1/4 minus 3/4.
Negative pi over 2.
Yeah, we'd have negative 2/4, which is also just negative 1/2. But I have a pi on top, so negative pi over 2. And then my last step is just to divide by negative pi over 2. Yes, no, maybe so. Okay. And then once we have all of those variables, we can just put them all together. So I have y equals, our a value was 3. Our b value was 2. Our c value we just found as pi over 2. And our d value was a minus 1. So then that would be our final equation. Yes, no, maybe.
I'm still a little bit confused on C, like how to find C.
So again, we're trying to take an old value, and so I'm setting it equal to where it happened on my parent function, which is where we got the pi over 2. Because sine normally has a maximum at pi over 2. But now my maximum is at 3 pi over 4, so we're trying to figure out how did my c value move us from pi over 2 to get to 3 pi over 4. And then I plugged in 2 for my b value here. Yes, we're going to look at another example, so that hopefully that might help some more. Alright. Okay, so looking at this one, I'm going to make it a little bit bigger. There we go. So since the table shows the depths in water at the end of a dock every 2 hours from midnight to noon, where t equals 0 corresponds to midnight. Use the trigonometric function to model the data. And then it wants us to do some stuff after that. But we need our model, which is just another word for an equation, first, before we can find the other statements. So it tells us that we are going to use a trigonometric function. You could technically use sine or cosine, but again, we're gonna stick with our sine. Are we okay with that? So which one do we want to find first? D, sure. So remember we said that difference about this one is that instead of looking at a graph, I'm looking at a table. However, those values are still fairly easy to find. So again, maxes, I'm looking at my y's. So what's my maximum y value here?
11.3.
11.3. What's my minimum y value?
0.1.
0.1. We're okay with how I picked those two values. I'm just looking for the maxes in the middle. So then we have to be 11.3 plus 0.1 divided by 2. So we should get, I believe, 5.7. Okay, we would just type that into a calculator. Are we all okay with how I found D? Again, same formula, it's just from a different set of data this time. Okay, so what do we find next? A. Okay. And remember, really the only difference between there is that instead of finding the average of them, I'm finding the distance. So remember that we just subtracted instead. So I'm still using that same max and min, so 11.3 minus 0.1 divided by 2, which gives us 5.6 instead. Alright, what do we find next? Our b value, which we found from the period, right? So we need to find our period first. So remember the period is, we took the, we used the max, no, I think we used min x2 minus min x1. Yes? Are we okay with that? So looking at x's now. Okay. I have one minimum. Do we see another minimum that gets me to 0.1 or really, really close to 0.1 on my data? Not really, no. Okay. Well, if I think back to my graph, I could also do two maximums, right? That would also give me a full period, just like two minimums would. Are we okay with that? Okay. Do I have two maximums or two things that are close to 11.3? Not really, no. Okay. So what can I do instead? Yeah, but again, the problem is like if we've shifted up or down any, then those aren't really like zeros anymore. Well, remember that we said the nice thing about our sines and our cosines is that they are all very like symmetric or like evenly spaced, right? So remember that where does a maximum have to be between my two minimums?
Halfway in the middle.
Yeah, exactly half, right? So I did, or I was able to label a maximum and a minimum. Agreed? So how much of my period would be my max to my min?
Half.
Yeah, half of the period. So could we still find that distance, but then just multiply by 2 now instead? So depending on what type of information is given to you, you might have to like just switch up your formula a little bit. So in this case, we're gonna do our minimum comes later. So we're gonna do our minimum x minus our maximum x, and then we're just gonna multiply that whole thing by 2. So what's our minimum x value?
0.
So this is my minimum, right? I'm just looking at the x value that's associated with that value.
10.
10. So then what's our maximum x value? 4. So 10 minus 4 gives us minus 6 times 2 gives us 12. So then again, we're doing the same thing we did last time. I'm going to take our period equals 2pi divided by b. So now we know that our period is 12. So I'm going to multiply by b and divide by our 12. So our b this time is pi over 6. Uh-huh.
And why did you choose 2 and 4?
So again, remember that, like I said, and the same thing over like on our graph, right? Maxes and mins are really easy to find, right? It's like the highest point and the lowest point. Same thing usually with our data, because like, right, it's really easy for me to figure out what the highest point and what the lowest point is. So I'm using my max and my min. But remember that our b values are inside. So now instead of using our y value like I did with d and a, I'm using the same point, it's just now I'm using the x part of it instead. Does that make sense? Other questions? Okay, we still have our c value fine, but we're running short on time and I don't want to like rush through it. So we will pause there. We will we'll finish this part up tomorrow, and then we will start your temperature lab.